Hello everyone, we've been given an inequality like this for the set of real numbers x. We're being asked, for how many different integers does the expression 2x plus 1 over x take a value? That's the question. First, we're going to simplify the expression here. Let's break this up as 2x over x plus 1 over x. Let's write the reciprocal of x so that we get the expression 2 plus 1 over x. Now, in the inequality, you're going to form this expression here. First, let's start with 1 over x. Here, the denominator of x is 1. Let's write that down. Now, my goal is to get to 1 over x. Here, it says x over 1. What are we going to do? Guys, with inequalities, we can swap the numerator and denominator. But this depends on certain conditions. First, in order to do this, the signs must be the same. Second, the direction of the inequality will change, guys. Look, positive, positive, positive. Okay, the signs are the same. So, let's swap them and see what happens. 10 is greater than 1 over x, and that's also greater than 5, friends. I also changed the direction of the inequality, as you can see. Or, how else can we write this expression? 5 is less than 1 over x is less than. Let me fix it for you as 10. So, what are we going to do now? Look, you've set it up here. You're going to add 2 to every side. Alright, let's add it like this. From here, 7 comes out. 7 is less than 1 over x plus 2 is less than 12, friends. They asked how many different integer values this expression can take. Friends, between 7 and 12, there are 8, 9, 10, and 11. It takes 4 different values, friends. Let's write it like this. Hello, guys? Given that x and y are real numbers, 2 inequalities are given. In this case, what is the largest integer value that the sum of x and y can take? That's what they're asking. Alright. Now, first, we're going to do a bit of rearranging in the inequality. Guys, because at the core of the question, they want the answer in terms of x and y, right? The answer? We don't have any issue with y, guys. It's written in the same format. The interval is also given. But pay attention here. Here, it's given to us as cube root of x. What are we going to do, guys? We're going to convert this cube root of x into x. Alright, how are we going to do that? You're going to get rid of the root. We'll raise it to the power according to the degree of the root. Okay, since the degree of the root is 3, I raised it to the power of 3. But what am I going to do with this 3? You're going to apply it to all the numbers. If you're doing an operation here, the others will be affected by it as well. So, if we make an adjustment like this, a 1 will come from here. Sorry, a 1 will come. What did we do? We got rid of the root. X is less than 2 cubed, which is 8. They've already given us the y interval. Exactly. If we come and write it here, it's done. Here, we're going to add side by side. Friends. Now, here's what we're going to do. Teacher, why is this part empty? This part doesn't matter. They already asked us for the largest integer it can take, right? We're interested in the upper limit. This part is important for us. If I add side by side, x plus y is less than, friends. I subtract 3 from 8, that's 5. They asked for the largest value that the sum of x and y can take, friends. The largest number less than 5 can be 4. Hi guys. Now, we've been given one equation and one inequality. Given that, b, what is the largest integer it can be? That's what they're asking. Okay. Now guys, the root of the question is asking for b, but the expressions have a's in them. So what are we going to do? If the question is asking for b, that means you need to get rid of a. How are you going to do that? We will express a in terms of b. Where? In the first equation, okay. If you isolate a, meaning if you move minus b to the other side, you'll find that a equals 5 plus b. Alright, now our job is easy. What does that mean? Like, a, I don't have anything left to do with it. Now, here, in this inequality, wherever I see a, I'm going to write 5 plus b, friends. See? Now we can move on to b. Like this. If we tidy this up, 7 is greater than 5 plus 2b is greater than minus 3. So what do we do now? Let's solve the inequality and see. Let's move the 5 to this side as a minus 5. Alright, friends. Let's also move it to this side as a minus 5. Let's see. Now, I subtracted 5 from 7. 2b is greater than 2b is greater than minus 3 plus another minus 5. That will make minus 8. I'm looking for b. What are we going to do for that? Friends, you'll need to divide every part of the inequality by the coefficient of b. Great. Let's simplify. 1 is greater than. B is left. Friends, from here, it's greater than. When I divide by 2, x, it will be x, 4. Now, what are the possible values we can take, friends? Here, it says it's between 1 and x4. So, it's 0, minus 1, minus 2, minus 3. What's the maximum it can be, guys? It can be 0. Are we good? That's it. Hello. Given that x and y are real numbers, we've been given two inequalities. In this case, what is the smallest integer value of x squared plus y squared? That's what's being asked. Now, the second inequality is what's important for us. If, in an interval, our lower bound a is negative and our upper bound is positive, and the operation asks us to square something, then the lower bound of this expression must be 0 or greater, guys. Why? Because as you go from negative to positive, friends, 0 is also in between. We took that because it's the smallest in terms of absolute value. Let me put it another way. Now we're going to square all of these, right? Let's write it out like this. Now these expressions, in this interval, we have minus 3, minus 2, minus 1, 0, and 1, right? Let's imagine squaring all of them. 9, 4, 1, 0, and 1 future correct. Yes, who came in youngest? None. If you think about it in this context, you will understand it more easily. Friends. So my lower bound is less than or equal to 0. Okay, now let's write the square of both. We will determine the upper limit. According to what? I'm going to square them, and I'll write down whichever of these two expressions is the largest. The square of negative 3 is 9. The square of 2 is 4, friends. So we take 9. Are we clear? Great. We also had an equality here. Let's write that down too, like this. Super. If it's positive, there's no problem at all. I'm squaring all of them. Are we clear? Now let's write it by reversing the direction of the equality. Look, 1 is less than the square of 1. Guys, y squared is less than or equal to. Actually, let's write it like this. From the square of 3, we get 9. Now let's add them side by side. Let's see. All right? And I added 0 as well, guys. 1. One of them has equality. The other doesn't. That's why I'm not writing it. X squared plus y squared. Look, both have equality. So I have to write it. I said less than equal. I collected 9 out of 9. 18. What did he say? Friends asked us to give the smallest integer value that the sum of these two expressions can take. Who can be the smallest greater than 1? It will be 2, this much. Hi everyone, now we will examine the absolute value question. What is the smallest integer x that can be combined? That's what was asked. Now, when you look at the question, the x's are common, and in fact, you can take the coefficients inside the absolute value out of the absolute value. For example, in this expression, when you take the 3 out, it becomes 3 times the absolute value of x. And guys, minus 4 will come out as plus 4. Let's take this one out as well. For times the absolute value of x is less than 28. Notice, aren't the x's common? Absolute values. So, you can combine the coefficients. I combined them here. It became 7. 7 times the absolute value of x is less than 28. If you simplify it nicely like this, friends, I want to continue from here. The absolute value of x is less than 4, friends. Now, you know how we open up the inside of the absolute value with both a negative and a positive? I'm going to do the same thing with the inequality. So, this means that the value of x here, friends, will be between 4 and negative 4. They also asked for the smallest value of x. In this case, it will be negative 3. Hello, x and y are real numbers. We've been given two inequalities. So which of the statements are correct in this case? That's what they're asking. All right, now guys, if the product of two numbers is greater than 0, that means the result of the expression here will be positive. Now, whether the inside of the absolute value is positive or negative, we always take it out as positive. Right? So I'm not talking about the sign of x. X can be negative or it can be positive. But what do I know? I know that this absolute value comes out as positive. Now, if I want to get a number greater than 0, friends, I need to multiply a positive by a positive so that my result is positive. Greater than 0, so it's greater. What happened? In this case, we see that the sign of y is positive. Okay. Now, I'm going to divide x by a positive number, and I'll get a result less than 1 for x. Guys, what does this mean? It means that the result of the expression here will be negative. So if we divide numbers with opposite signs, our result will also be negative. Therefore, we got x as negative here, right? So the sign of x is negative and the sign of y is positive. Let me show you a quick sign multiplication. I'll try to explain it more clearly for you. X is less than x. I'm multiplying y by -1. Negative y. Now the sign of y is positive. This operation is negative, okay? Normally, when talking about real numbers, you shouldn't assign values. But I want it to be a bit easier to understand. I'll try to explain it in a softer, more approachable way. The question. Let's do it like this. For example, let's say x is 5. Let's say that. Let's assign a value. Let's also say y is 3. The result of the operation was -3. Friends, look what happened. -5. It turned out to be less than -3. Okay. So actually, a more organized version of this means the following. So, the absolute value of x actually means it's greater than y. That's how I'm interpreting it. By giving you a value. Alright, I'm doing it this way so it's a bit easier to understand right now. Now, let's take this and interpret it together in the statements, in the premises. I said x is -5. Okay. Look, our operation sign is negative. I called the value of y 3. If I add this up, -8 is smaller. From scratch, the first premise is true. Okay. Let's look at the second lead. I called this -5. I said the value of y is 3, friends. So look, if I add it up, it looks like this. This is less than -2 here. It has to be from 0. So our second premise is wrong. Let's look at the third premise. The sign of x is negative. The sign of y is positive. The product of two opposite signs is always negative. Guys, so it's less than 0. Our third premise is also correct. So, which ones are correct? Is what was asked. It will be the first and third premises. Guys, that's it.